In late 2023, I was able to purchase a Raspberry Pi 8 gig model, and I was very excited and happy to be able to get one that early because I was expecting with the COVID-19 pandemic, with the shortages of Raspberry Pis, it was very difficult to get your hands on any of them, at least not without paying scalper prices. And so I thought it'd be great to have one just to tinker around with. And about maybe 2 months or so later, after I got my Raspberry Pi, the 52 Pi came out with a 2.5 gig Ethernet hat. I think it was one of the first ones I've seen available, so I purchased that. So I waited about 6 months and I never got it. So I contacted them, they sent it right away. So I don't know if they lost my order or something, but I wasn't in a huge hurry to get it, even though I was at first, because I had to wait for the software to catch up to support the Raspberry Pi 5, because I kept checking on a couple different Linux based firewalls and routers software, and none of them were supporting Raspberry Pi 5, and some of mine had some preliminary support, so it wasn't working very well. So after a couple months of waiting, after I got the 2.5 gig hat, OpenWRT I noticed supported the Raspberry Pi 5 in some snapshot versions. And I tried that out a few months ago and I didn't seem to have any luck with it. It seemed like it was loading or anything. But then when I was looking at a recent post by Pine Boards on their website on how to set up OpenWRT on a Raspberry Pi 5, I realized in some other research I was doing that the snapshot builds do not include the web interface. So I was trying to access a web interface that didn't even exist. So I didn't realize that was the case. So you have to build the firmware manually or use their firmware selector, which allows you to do custom builds, which is a very cool feature that they have. But that includes the Lucy web interface. After trying the snapshot image as described in the Pine Boards blog post, I realized later as I was going to do this video that they have OpenWRT has a 24.10 release candidate, RC2. And I decided to use that instead of the latest snapshot build because I feel like the release candidates should be a little bit more of a stable build than the latest snapshot version. I went ahead and for this video demonstration showed how to get the version 24.10 RC2. And the great thing is that means the next version, when it's become stable, 24.10, that it's going to support Raspberry Pi 5 out of the box. But I wish I had to do the custom build on their website because I need the driver for the 2.5 gig Ethernet hat. With that said, here is the Raspberry Pi 5 with the 2.5 gig Ethernet hat on top. Out of the box, when you install OpenWRT, it's going to use the 1 gig interface that's on board as the LAN interface, and it doesn't automatically configure the WAN interface even though we have the driver installed. So we'll connect to the web interface on the 1 gig interface, and then we'll set up the 2.5 gig interface to be the new LAN interface, and then we'll make the old LAN interface the WAN interface. So that way we have two wired connections. This will be the WAN, this will be LAN, and then I'll set up a couple of VLANs on there so I can test traffic going across two VLANs on the same interface and see if we can get the maximum 2.5 gig throughput. And so that way we'll have two different PCs connected to a network switch, and we'll test that out. And also we'll test out the LAN interface, the 1 gig interface on a speed test server I have internally, and I'll show a speed test on the internet. So OpenWRT doesn't require a lot of RAM or storage because it's designed to be run on consumer grade hardware, which has a lot more hardware limitations and constraints. And so it's super efficient. So you could get away with using the Raspberry Pi 5 2 gig model and save like $30 compared to the 8 gig model that I have here. So for $50, you could get the Raspberry Pi 5 2 gig. And you could get this hat, I think it was $50 when I originally purchased it, but I think it's down to like $30. I don't know if that's the normal price now that it's been out for a while, or if it was just happened to be on sale at the time of this video when I looked at it. Between these two boards here, you can have it'd be $80, and then with a Raspberry Pi 5 power supply, you might be looking at another $15, $20. So you're looking at like maybe $95 to $100 for this setup here to have a basic travel router or home router. And so you have to kind of weigh if this makes sense for you compared to say like a cheap N100, Intel N100 system. So once we get OpenWRT downloaded and installed, we're going to plug into this 1 gig interface with a mini PC, and we're going to use that to configure this system to be an OpenWRT router. So if you go to the OpenWRT website, which is openwrt.org, you'll see this homepage here. And what's interesting about their website is not only do they have pre-built images, but you can go and do a firmware selector and build your own images from the website. It's a pretty cool feature, but just keep in mind that occasionally it does break. I was going to do the video a little bit sooner, the recording of this video, and I was going to have to do this the long way by not having a pre-built image, but I'm glad they got it fixed in time for this video so that I can show you how this works. But if you go down to where it says the current stable release, let's go to the next stable release, and we'll go to where it says download a firmware image for your device, and it says firmware selector in parentheses. So let's click on that, and up here at the top you'll see, if I search for Raspberry Pi 5, you'll see that it shows up in this list. Note that if I change this version back to the latest stable version, 23.05, it doesn't even have a Raspberry Pi 5 image available. So it's only available on the release candidate for version 24.10 and the snapshot version. So I go to snapshot or 24.10. You probably get a little more stable experience by picking this release candidate. With the release candidate, they do have the web interface built in. So if you click on the factory image down below, it will have the web interface, which is what you want. But what we're going to do is there's this option here in the middle. It says customize installed packages and or first boot script. If you click on this, it's actually a drop down, and it shows all the packages that are going to be built. You see how Lucy's in here at the very end, so that means that's the web interface. But what we're going to need to put in here, which I have copy and pasted, since I want to use the 2.5 gigabit Ethernet interface, you need to have the R8169- firmware and the KMod-R8169 packages installed, because this will enable the 2.5 gigabit interface to work. What's interesting is Pine Boards in their blog entry, they use this same firmware and package included in their blog, but they're trying to get a 1 gigabit interface and one of their hats to work, but it also happens to work with the 2.5 gigabit interface. So some of these firmware versions, it might not just be this 8169 model, because I believe when I looked up this 52 Pi hat, I think it's like 8156 or something like that, is the 2.5 gigabit version, but they don't have that package with that name in OpenWRT, but this works, so I'm just going to go with that. And then you click this button here to request the build, and you'll see up here, once you click that, it's going to tell you that it's going to be building. So you'll see if it built successfully or not. So once your build is successful, you'll come down to this factory and sys upgrade section. There's two different ones of each type. When you're doing a first time installation, you want to pick a factory image, and there's ext4 and squash fs. And it's interesting, the differences between these two. Like if you're using, like say, consumer grade hardware, you'd probably want to do the squash fs, because this is like a read-only type file system. So you would probably use a squash fs potentially if you don't want to install any plugins or whatever, and you want to have everything pre-installed already, and it makes it kind of like a consumer grade router where you're not adding packages. But if you want to be able to add your packages on a, like you normally would on any normal operating system, you probably want to do the ext4 version. And so there's reasons for wanting to use squash fs, but most of the time you probably want to use the ext4 version. And if you're doing just an upgrade to an existing version, you probably want to use sys upgrade. I haven't tried that before. So let's click on factory ext4. So you'll see at the bottom when I hover over this, it's going to have a long random generated string alongside the version number, and that indicates that it's a custom build. So that's no way you can verify that this download is a custom build and not just the release candidate that they have pre-compiled for you. So let's go ahead and click that, and you'll notice if I click it, it just shows all this binary gibberish. For some reason, when you do a custom build, it does this. So hit the back button. So the best way to download this is right click and click save as, and then that way it'll actually download the file. I think there's something wrong with the way they produce this link on this web page for custom builds, but it's not that big a deal, because you can right click on it and it's save link as, and save it to your file system. So now we have that file downloaded, we're going to image it onto a micro SD card, which I have here, and I'm going to show that process. I'm not going to be using like an NVMe or a USB or anything like that drive for this, but you could do those alternate storage solutions. Just keep in mind, if you're using NVMe, you're likely going to be sharing that PCIe bandwidth with your Ethernet interface, so that could affect throughput. So now I've opened up Etcher, which I like using this just to flash SD cards when I'm not using any of the Raspberry Pi images. So let's go pick from flash file. So I just picked the image that we just downloaded, and I'm going to select the target of the SD card and hit select, and we're going to flash it. I've got to type my password in here. All right, so now it's going to flash. It's not going to take very long at all because the firmware that you're downloading is only 13 megabytes. Now that we got this flashed, we just need to insert it into the Raspberry Pi and we will boot it up. It's going to use the onboard 1 gigabit Ethernet interface as the default LAN interface. That's what you want to plug your computer into so that we can get access to the web interface. Now that you've plugged the PC into the Raspberry Pi's 1 gigabit port, we should be able to access the web interface, which is 192.168.1.1. If it defaults to HTTPS, which some browsers like to do, you can just delete that S off there. By default, the web interface is not HTTPS. I'm sure you can probably change that later, but I'm just going to log in with root and with blank password because there's no password by default. So it'll tell you need to set a password. I'm not going to worry about that right now, but that's something you'll definitely need to do. And you'll see that I'm on the Raspberry Pi 5 model B revision 1.0, okay? And so it's pretty cool to see OpenWRT on Raspberry Pi 5 without a lot of effort to get it to work. So as you can see down here, it says we're using only 74 megabytes of RAM. This is why you could get away with using the Raspberry Pi 5, the 2 gig model, to save on money instead of getting the 8 gig model like I have. You know, I got it to test other things. And so as you can see down here, the disk space is only using 24 megabytes of space, which is pretty crazy. It defaults to using 100 megabytes of space. It's probably like a safe default because if you're putting this on consumer grade routers, they might have only megabytes of like storage and RAM, so they don't have gigabytes like these mini PCs. And so as you can see, we have the 1 gig interface. It's already configured by default. That's what we're plugged into, and it shows the machine that we're connecting from, which is a Protectly V1210. And let's go up here to what we need to do is go to network interfaces at the top here, network interfaces, and we're going to add the 2.5 gig interface so that we can have a WAN port and a LAN port. And we're going to make the 2.5 gig is going to be our new LAN interface instead of this 1 gig interface. That way we can take advantage of 2.5 gigabits between VLANs. So let's go ahead and click on add new interface here. You should see when you click on the device down here, you should see an ETH0 and ETH1. ETH0 is the built-on 1 gigabit interface, and ETH1 is our 2.5 gig Ethernet interface. If you don't see ETH1, that means your network card is not detected, either because you have the wrong driver installed, or you're missing the driver, or you don't have your ribbon cable connected very well on your Raspberry Pi for your PCIe Express port. So let's click on ETH1, and we're going to call this LAN 2 for now, just so we don't conflict with LAN, the default LAN. And we're going to make this static. This is be similar if you're following my OpenSense guides. You want your interface, network interface, to be a static IP, but then you enable a DHCP server. So it's kind of a similar process to how we would do this in OpenSense. Okay, so let's go to static and we'll create this interface. And we're going to go down here and enter an IP address. I'm going to default it to .2 because we already have a .1 interface. So we're just going to do this. We're going to move back over. You can change it back to .1 if you want, but I'm just going to do this for illustration purposes. You can change it back later if you want. You can also set up IPv6 here if you want. So for this demonstration, I'm just going to quickly just do IPv4 since I can just set that up really quickly. IPv6, a lot of people I know like to see that nowadays in the modern era, but just to show this demo, the purpose of this is to show it running on the Raspberry Pi and not get in a deep dive of OpenWRT, which I might do in the future. But for now, we're just going to just do a quick setup so that I can test a few things and show that it works. Okay. So, and if we go over, we want to go over to the DHCP server and click on Setup DHCP server. Otherwise, you won't have any addresses when you plug into the 2.5 gig interface. Okay, we could probably leave the defaults because it's going to set up 50 IP addresses. You can set the range. It starts at .100 and the limit is 150. So actually, there's going to be 150 IP addresses there, not 50. I thought that was the start and end, but that's the limit. So it's probably fine to do that for now. If you need more addresses, you could do that. And you can hit save and apply changes so it would actually pick up on this interface. All right. And One other thing I forgot to do, let's go back to edit. I noticed it shows that it's grayed out. So we need to go to firewall settings, and we need to just go ahead and add it to the LAN zone, because if you don't add it to the zone, it's going to not have any zone, which I think blocks all traffic because there's no zones defined for the firewall. The OpenWRT, I believe, it seems like it acts more like a zone-based firewall, which is a little different than OpenSense. And so we just do this for now because you probably would want to create different zones for different VLANs. I'm not sure if that's the best practice. That's more things I need to dig into and research more for OpenWRT. That's not the purpose of this guide. So I'm just going to do this so that way it's enabled. So let's hit save and apply for the change we just did for the zone. All right, so now we have LAN 2 is green. So what we could do now is plug our PC into this 2.5 gig interface and see if it works, because we should have enough configuration now to be able to connect to that interface. And you'll know if your interface works if you're using the 52 Pi or another hat. There's usually a LED light on top that will light up to show you that you're connected, and then you'll see on my PC at the top will show that it's connected. Okay, depending on your operating system you're using, you might need to do a disconnect and a reconnect, or a DHCP release and renew. Sometimes it hangs on to IP addresses. I know with Linux here, if I disconnect or reconnect real quick, it still hangs on to the old IP. So if I go here and I do IP space A, I can see that I'm now in the .2 network. So I can now access hopefully the web interface at .2.1. What's interesting is because of the firewall rules, I just put it in the LAN zone. I can probably still access it from both. Yeah, so I can still access from either one, but we're going to do .2 because I'm going to get rid of the other LAN interface and make it a WAN interface. So let's do that. And we'll just log back in, and you can see we're back to our page that we're on. And now I'm connected to LAN 2 and it works just fine. So now what we're going to do is we're going to just delete this interface, the LAN interface, because now we're connected to LAN 2, so we shouldn't have any repercussions for doing this, because we're just going to create a WAN interface. And the reason is I don't think you can rename this interface easily after you create it, but this way we'll make sure we don't have any LAN type settings on this interface. So let's go ahead and hit save and apply so we can just get rid of this interface. And then we'll create a WAN interface, and then we can see if we can maybe rename this interface. I'm not sure if we can or not. Let's see. Let's go to add new interface, and we're going to be a DCP client, and we're going to call this the WAN interface, of course, and it's going to be ETH0, and we'll hit create interface. It's going to be a DCP client. What we need to go to is here on there. It automatically put it on the WAN firewall zone. And we don't need any DHCP servers on this interface. All right, so we should be able to hit save and apply. Let's go ahead and plug the WAN interface in to our gigabit Ethernet interface on the Raspberry Pi. So I want to do that now, and then we'll test out that connectivity. So I plugged the WAN interface in, and you can see there's some transmit and receive packets that are already showing up here. And you can see here that it pulled a IP address from my lab network. So this is what I'm using for my WAN connection. So that's how I know I'm on the proper network. And you notice up here with the icon here in Linux, it shows that I'm connected to the internet, because it was showing a question mark there, meaning that you can connect to the network, but connectivity to outside world doesn't work. So let's go ahead and log in and see if Google shows up. So we now have internet connectivity. So that's pretty simple to set up this interface. We just deleted the other LAN interface, the original, create a WAN interface, and we're good to go. So one thing I want to test, I have another browser open, and I already have the fast.com open. I'm going to run this, and I should be able to get close to a gigabit, but I'm behind another router, and I seem to get between 600 and 700 megabits. I'm not sure why this test is slow. I don't know if it just doesn't work well behind a double NAT for some reason, because I have a speed server set up with using Libre Speed, a self-hosted speed test server, and I'm going to test this out on my local network, and it's going across from my LAN interface of OpenWRT through the WAN interface of OpenWRT to a server that's on the lab network, on the 110 network, and you can see I'm getting full gigabit throughput here. So it's obvious that I can, with this test, get full gigabit throughput on the Raspberry Pi through the 1 gigabit interface that's on the WAN. And so one thing I want to test is creating a couple VLANs, and I want to see what the speed is between the two VLANs. So that's going to be kind of interesting. So I set up the VLANs on the switch ahead of time. So all we need to do is go back to my configuration here, and I'll show you how to set it up real quick on OpenWRT. And it's not too bad. You just have to go over to Devices tab, and then you add a device configuration. This is sort of similar to OpenSense because you're going to pick a physical interface and we're going to create a VLAN on top of it. I noticed when I looked up how to create VLANs in OpenWRT that there was a legacy way of doing it, and then there's a newer way of doing it. And I think the interface only allows you to do the new way now, since I'm using a newer version of OpenWRT, and that's changed since a couple versions ago. So this should be the correct way of doing it, but I'm still new at OpenWRT, so just take it with a grain of salt. I'm just going to show you that VLANs do seem to work if I do it this way, and because I have it configured on my network switch, and I'm able to get different IP addresses and different subnets on the VLANs and be able to communicate between them, because I'm not really going to set any firewall rules. I'm going to put everything on the same LAN zone, so I'm going to just have straight routing between the two interfaces, and so we'll see what speeds we get. So we're going to pick the VLAN 802.1Q, not the 1AD version. I wish they would spell out what that is, because this is your standard VLANs, and the other one is they usually call it like a private VLAN. So it's like a VLAN inside of a VLAN. So that's what this one's for. I think they call it Q and Q as well, VLAN, because it's like 801.1Q. So it's a Q and Q. So you got a VLAN inside of a VLAN, but we're not worried about that. We're just going to do regular VLAN, and we're going to pick the base device where we want it to be ETH1, which is going to be our LAN interface, is our 2.5 gig interface. And we'll just do kind of like we do in OpenSense. We'll do VLAN 10, and we'll just hit save. And then we'll add another one for ETH1 and 802.1Q VLAN 20. Of course, that cleared out my device again. I got to pick it again. Okay. 20, and then we'll hit save. MTU default is fine, so we hit save. All right, now that we have the devices here, we hit save and apply. This basically just creates the VLAN on that physical interface, and then we have to go to the interfaces and actually assign them, like very similar to OpenSense. So we're going to add a new interface, and we're going to call it DMZ, and then we'll just make up one, and we'll just do static IP address, and the device we're going to pick, you'll notice there is this VLAN down here, .10, .20. So these are our software VLANs, because it's a software logic based network, right? And we'll go create. Okay. So for the IPv4, we're going to type 192.168.10.1, and subnet mask, we'll just pick the first one. This is basically the same as the /24 if you do CIDR notation, and by default, this is your default gateway here. It's going to use the WAN connection. We only have one WAN connection, so we don't need to set anything here. And we're just doing IPv4, so we'll just hit save. Before we hit save, I always forget, we got to go to firewall settings. We're going to put it in the LAN firewall zone, DHCP server. We'll just hit set up DHCP, and we'll leave it to default. Okay, we'll hit save. So now we have a DMZ network, and then we'll just call this next one IoT or whatever. We're just making up stuff here, right? So we got static IP address. We're going to pick .20. Notice, like in this dropdown, once you assign that interface, it has the name beside the one we just added. So that'll be nice. It helps you identify what these interfaces are used for. So hit create interface. We'll go static IP 192.168.20.1. Same subnet mask as before. Firewall, we're going to make it LAN, and then DHCP server, we'll hit set up DHCP, and then hit save. And then we want to save and apply these changes. So now what I'm going to do is I'm going to plug my PC into, let's say, the DMZ network, and I have a second PC I'm going to plug into the IoT network, and we're going to see a iPerf speed test between them, and we'll see what speeds we get, and then we'll come back in here and we'll check out some real-time graphs or whatever, and we'll see the traffic flowing through the interfaces. All right, so now I plug everything in. Let's do IPA, and I disconnected, reconnected like I did before, and you can see I'm on the .10 network, so I'm in the DMZ network, and I'm going to have a machine in the other network connected. If I go to overview Let's see if I can see both these machines connected. Yep, so there's my other machine here. It's on the .20 network, like as we expect. So now I know what the IP addresses are. I'm going to just do an iPerf speed test here and see what we get. All right, so now I'm going to run a speed test here, and I'm going to connect to that network, and you can see I'm getting close to 2.5 gigabits. This is pretty close to the theoretical max. Usually can get about 2.3, 2.35 or so. So we're getting full 2.5 gigabit throughput here, which is great across the interfaces. And let's see what happens if we go to real-time graphs here, and we can check out the bandwidth. Here we go. There we go. So now we can check out here's our DMZ network. You can see we're close to 2.34, and if you look here, 2.34. And this is outbound on this VLAN 20, and this is inbound on VLAN 10, which is our DMZ network. So you can see it's outbound full throughput, inbound full throughput at 2.5 gigs. So that's pretty good. It's pretty awesome that we can get that on the Raspberry Pi 5 without any problems. And so it's a kind of a good visual way to see that we can get that full throughput coming across, which is great. I hope this video can demonstrate just how viable a Raspberry Pi 5 can be with a 2.5 gig Ethernet hat running OpenWRT, to use as like a basic home router or travel router. This thing performs quite well, and this is the first model of Raspberry Pi 5 where I feel like you could really use this as a legit router for your network without being underpowered for the purpose of just a basic router with basic firewall. And if you want to do IDS, IPS, this is not going to probably cut it for you. Just for basic needs though, this little device could handle probably a lot of basic home network scenarios. And you got a lot more functionality with OpenWRT than you would a consumer grade router that's not running OpenWRT firmware. So you got VLAN capability, you got firewall capability, and you can run various packages and stuff on top. And I think you can even do like Suricata for IDS, IPS. Not sure how good that's going to work on this. That's not what the purpose of the video is, but you can still do a lot with this. I'd be interested to see how good you can run like different VPNs off this as well. I haven't tested that yet. I'm pretty excited. I finally got to do a project with this 2.5 gigabit Ethernet hat from 52Pi, and to test out how viable it really is. And I was very happy to see that it is viable and it does work at full throughput. It's not throttled or anything like that. So I hope you enjoyed this quick little demonstration, and maybe I can do some more stuff with this in the future if you're interested. I just have to get some time to play around with this, but until next time, I'm Dustin Casto, and I'm signing off.